these are the notes and the example problems for the relearning and retake for the logarithms unit that we completed not long ago, modules 14.4 through 14.6. So you can follow along with this video, work through the exercises with me. Not a bad idea to pause the video, try them on your own, check your work. You can take whatever notes you want that you think will help you over in this section here to the right. And once you've completed these 5 practice exercises along with me, flip the page, use this page as notes if you want, and try and work through some very similar exercises on the next page and answer a couple of questions on the last page. And I'll grade that, and that grade will take the place of your quiz grade from 14.4 through 14.6. So keeping in mind, as we think about logs, there were 2 related expressions. If I have a base b raised to an exponent x, and that's equal to a value y, the related log expression, the same relationship between these 3 numbers here, the log base b of y is equal to x. So the log is the exponent. So when we have an expression such as log base 5 of 125 equals 3, and I look at this expression, log base b of y equals x, so 5 is my b, and 125 is my y, and 3 is my x. Let me look at this relationship here. So I want the base b, which is 5, raised to the exponent x, which is 3, and that's going to be equal to my value y, 125. And we can see that this makes sense intuitively. 5 to the third equals 125. 5 times 5 times 5 is 125. The log is just another way of writing the same relationship between those values. Let's go the other way now. If we're rewriting this in log form, b to the x equals y, I want to write log base b of y equals x. So my base is 2, so log base 2 of y, the value, we'll call it the argument, is equal to x, the exponent. Log base 2 of 32 equals 5. All right, in example number 3, condense the log and solve the equation. So we learned some rules about condensing logs. If I have a log of a value that can be separated out into 2 factors, a product of 2 factors, I can rewrite the log with each factor getting its own log, and I'll take the sum of those, whatever the base is. Log base a of m to the n, log base a to the m, plus log base a of n. If I have an expression that can be written as a quotient, I can rewrite that as the difference of 2 logs, log base a of m, the numerator, minus log base a of n, the denominator. And if I have a log base a of some value to an exponent, that exponent can be written out in front as a multiplier. So I'm looking at these, and remember these go backwards. I see that I have 2 logs added together, and they're the same base. Log base 7 of 4 plus log base 7 of x. Well, by my product rules here, I can rewrite this as log base 7 of 4 times x. And that's equal to the log base 7 of 20. Well, now these are the same bases. Log base 7 of 4x equals log base 7 of 20. The only way this expression can be true is if the arguments are equal. 4x equals 20. Divide by 4, divide by 4, so x equals 5. So condensing this log allowed us to write one equation that we could solve for the value of x. Okay, so conversely, now I'm given a log that I can expand. 13 times the square root of x, this is a product. So I look back at my set of log rules here, and I know that when I have something that's written as a product, I can write that as the sum of 2 logs. So log base 3 of 13 plus the log base 3 of the square root of x. But remember, the square root of x is the same as saying x to the 1/2 power. So now I've got a log expression where I have an exponent. So I need to separate this one out. Log base 3 of 13 plus 1/2 log base 3 of x. All right, last one. We're asked to use our calculator to evaluate log base 4 of 13. Now, keeping in mind that the log button on your calculator is base 10, this is base 4, it's not the same thing. Remember that those are different bases, 4 to some power versus 10 to some power. Those aren't going to match up. So we have something called the change of base formula. Log base A of x is equal to log base 10 of x, the argument, over the log base 10 of my original base. Log base 10 of x over log base 10 of a. So the log base 4 of 13 could be written as the log base 10 of 13 divided by the log base 10 of 4. So to your calculator you go. Remember, if you take your phone calculator and put it in landscape mode, you've got a scientific calculator that you're carrying around. So we type in 13 and then log, and I get 1.1139, we'll round to 3 places, 1.114. The log base 10 of 4, 0.602. So when I divide those two out, I get 1.850. So the change of base formula allowed me to use my calculator to evaluate this log expression. All right, take your time. If you want to go back and re-look at any of these examples or take more notes on the side, you can. When you're ready, flip the page, work through the similar exercises on the next page. You can use everything you wrote down here as notes to help you and answer the questions on the last page.